Question number 1 said the downward movement of water from location A in the given diagram will usually be greatest when the soil is. My question is, what did you guys think downward movement meant? And I'm not judging, I actually want to know what you thought. So only those of you who got it wrong, if you got it right, just please keep getting it right. So here's A. What did you think downward movement was? Down the hill. How many other people thought down the hill? You got it right. Okay, then you got it right because you got it wrong. Then that's not any better. So pay attention. If you thought it meant down the hill, did you answer C? If you answered C, so Cody, you thought, what did you think downward movement was? Okay, great. Okay, that's not it then. Did you guys think? Answer C. Who did answer C? That's it? Okay, you guys didn't think the same thing most people did. Like me, I will add 5 points here. So guys, just to clear this up. So Cody, you're down, but that wasn't, you weren't quite thinking. Downward movement of location A. Here's A. It's not. It's rain's here. You couldn't be thinking about rain there. I want downward movement. Can you guys point down for me? Okay, because I'll know what down means, right? Do you see how that's different than downhill? Which way would downhill be? Yeah, like on an angle. So that is what's going on here. Downward movement is going down from A. It's that part. They would have said downhill, I believe, is how they would have worded it if they were talking about going from A to B. I do see where a lot of you might have gotten that confused. So if you were thinking downhill, then yes, that's runoff. Then yes, we want non-porous, which, hey, can you guys tell me what non-porous means? What's the non part? Okay, so I guess it means water can't get through. It means there are no pores. So this is porous. There's all those pores. Non-porous is this. There are no pores. Water cannot get through it.
No, during I was thinking about when this pour out from
Yep. So pores are the holes. Non-porous would be with no holes.
Did you give me credit if I said the right answer right now?
No. Didn't I already tell you the right answer?
See?
No, it's not D. And the reason it's not D is because of the small size. The best way to get A down into the ground would be if it was porous and had large holes. What did you say? What did you get?
I think B.
Oh, okay. So in this case, number 1, the answer is B, because we want there to be we need there to be holes, and we want them the bigger the better for getting water to go through. What would most likely reduce the amount of runoff at B? So we want a smaller amount of runoff. So guys, I have to ask you, if we want less runoff, what do we want the water to do instead? We want it to infiltrate. We want it to go in better. So if we read through, will A make there be less runoff, a greater condensation than evaporation? No. First of all, does that have anything to do with runoff? Does not. Would there be a greater amount of runoff if the soil was saturated?
No.
No, because what would happen if I had saturated water and it was raining on top of it? It would sit there or run off if it was downhill. So we want to reduce the amount of runoff. If the land was frozen, would we have less runoff? No, if the land was frozen, we'd have more. Now let's double check to make sure this makes sense. Would we have less runoff if infiltration was happening faster than precipitation?
Yes.
This means soaking in more or soaking in faster than it's raining. All right, now we want the greatest amount of transpiration and evaporation. to occur if the air temperature is, how do we make things evaporate faster? Let's start, do we want high? If the temperature is high or low, do we want to start which one? High or low? High, so we get rid of the low one. Do we want humidity low or humidity high to make things evaporate? We want low humidity. Guys, you see how I'm crossing? I underline, I'm crossing off answers. Can I show you my answer key? So I did not, the computer didn't give me an answer key for this one. I had to go through and take the quiz myself, which I can handle as the teacher. I could still get 100, but look, I underline, I cross off, I add labels. Like, this is my answer key, and look at me crossing off, underlining. If I had a highlighter, I might have highlighted it. So what I'm saying is, guys, if I'm doing it, and this is my job, you should be doing it, because you're not an expert.
I messed up with the humidity.
Yeah, we want low humidity. The drier the air, the faster it evaporates. I also have another question here. Did you read this? Did you read the picture too? Okay, it's really important that you do that. Otherwise, you might think that they were just pouring water in. But in this case, so the diagrams below represent 4 columns A, B, C, and D that are partially filled with equal volumes of dry sorted sediment. A fine wire mesh covers the bottom of each column to prevent the sediments from falling out. The lower part of the column has been placed in a beaker of water. So they're not dumping water in from the top, they're taking them and sticking them in a cup of water. Because they want the water to be sucked up from the cup into the soil. In fact, it says, capillarity will cause the water to rise the highest in which column? This you had to know, capillarity action. What works better, small, medium, or large? Small, the smaller the better. So we want to find the smallest out of these. Which one is the smallest? It's anything silt. But see how they mess with you? They picked the word, use the word small here. If you picked this because it said small, I'm okay because you got the right concept. But you still need to understand that silt is the smallest. So that's answer C. I don't know why I was, okay, because A is the, I don't know why my gut wanted to say A there for a second. I was no longer paying attention. This number 5 was a vocab word we learned the day of that lockout down, whatever it was called. So if you weren't here and never made up the work, this right here you got wrong. So the dashed line, notice it lines up with the ocean. It goes to the top of the zone of saturation. It's above the groundwater. That is marking off D, the water table. The water table is really just how far down you have to dig to hit water. Which change in the surface water movement will likely occur when vegetation is removed from the side of a hill? It is answer A. Let's talk about why. So first of all, we did a homework assignment that was like legit the same question. Maybe not word for word, but it was certainly the same concept. Right, must be right here. The top of page 10, we did this question. And I compared it to a baseball field. Let me ask you again, in a baseball field, where are there more puddles, the infield or the outfield? The infield. What's the difference between the infield and the outfield? Versus grass and dirt and soil. The key is the difference that I want to talk about is the grass versus the dirt. Because that is this exact question. We remove the vegetation. So I take the grass away. And now it's like the infield. Why does the infield? So because it's like the grass, or because it's like the infield, we'll have less infiltration because the grass allows for more infiltration to happen. And then runoff If we have less infiltration, we'll have more runoff, because if it's not soaking in, where's it going? It's running off. There was lots of people who had the right answers, I could see, and then they crossed it off. It happened multiple times on this test. So I think it was just a lack of understanding the vocab words, and you were second guessing yourself over and over again. This question, I kind of was mean for this one. Because yeah, there was a huge reading. And then there were pictures. And then there was a table. And I'm going to tell you, I never ever once talked about water retention. We've talked about water going through things. We've talked about water going up, but I've never talked about water retention. And that's because New York State, that's not on their list of things I have to teach you. So I feel like I teach you a lot of things. I don't teach you about water retention, but this is how they like to do this. They kind of taught it to you here in this question. Then they gave you a table, and then they wanted you to basically interpret that table. This was more of an interpreting words question than a using your earth science knowledge. And in the end, it says the general relationship between particle size, and the amount of water retained. What is the general relationship? So we kind of got to look at this table. Pebbles, pebbles, sand, sand, silt. What do you notice about those? Okay, so they start off at the biggest and they go down to the smallest. So I'm going to start as particle size decreases. What happens to water retention? Water retention increases.
And I know what it meant, I just want to.
Yeah, so what happened is you thought it had to do with stuff I taught you, which would make sense, right? Ms. Ritz is gonna quiz us on the stuff she taught us, but I'm also gonna quiz you on making sure you can answer questions, the way they're written. So I just wanted you to compare particle size to water retention.
I said smaller the size, the more water.
And you got it right, I hope, right? Yeah, then that was perfect. Yeah, so you can rearrange these words to mean the same thing. So I also wrote larger particles retain less water, smaller retain more. So as long as your answer meant this, I'll accept it. So did I mark anybody's wrong and you're not sure I should have marked it wrong? Okay, and now question 8 now changes the whole question. And they say, name the particle type used in the investigation. So these were your choices. That most likely had the greatest permeability. What does permeability mean? The way it goes through, the one that goes through the fastest. And which one do we know? The biggest to the smallest. The bigger works better. So coarse pebbles. Now I have a word of warning here. I did accept larger particles or largest particles. However, if this was the exact regions question and they said, name the particle type used in the investigation, your answer had to be one of these, because they're first testing that you know the largest concept, that the larger has the higher permeability, and they're testing that you know pebbles are bigger than silt. So just again, read the question carefully to make sure that you're answering what they asked and not what you think they're asking you. There's a difference. This one's, again, I think it was a vocab question, a vocab word problem versus a knowledge problem. So we want to draw the relationship between bead size and capillarity action. You get these blank graphs with just arrows on it. What does it mean, like right here for bead size? 0 or really small. Yeah, so this end is the small. And the fact that the arrow goes this way, what's that mean? They get bigger. So as we go this way, they get bigger. Now capillarity, when we start down here, what does that mean? This is a small or a low capillarity. Up here is going to be a high capillarity. Same thing here, permeability is low, permeability is high. So then you got to stop and say, just kind of like graph it in your head. If I have small beads, Do we have high capillarity or low capillarity? Small beads. Capillarity is best with small.
Oh, then I got it right on.
Good, so that's high capillarity for small beads. And that's a concept you just gotta kind of remember. And remember, I told you to remember because capillaries are the smallest blood vessels. Smallest. That's the key word there. They're the ones in your eye, those teeny tiny blood vessels in your eyes. They're tiny. The smaller, the better for capillary action. Capillarity action, sorry. So if small beads are high, what are big beads? They have a low capillarity action. So when I connect those, I get a down graph. Permeability. Ability of water to flow through. If we have small beads, those aren't the small ones, sorry, small beads. Does the water soak in fast or slow?
Slow.
Slow. That's a low permeability. Big beads. Fast. That's a high permeability.
I switched mine.
Lots of people switched them because I think you weren't thinking of what the vocab words meant. A lot of people, can I throw up the last graph that most people drew as well? They had bead size. And their graph looked like this. What's that mean? Stays the same. Doesn't matter the bead size. What is bead size? What is that really a graph of? It's not capillarity. It's not permeability. Porosity.
Yeah.
You were good. I knew what you meant. That's porosity. Porosity, it doesn't matter if we have a small or a big bead, it's always the same. Speaking of that, kind of goes with the last question. Describe one way to prepare a fourth container of beads filled to the same level as shown in A, B, and C that would reduce porosity. So we just said right here on this graph with porosity, size doesn't matter. So it's not make the bead smaller or make the bead bigger. That would change the permeability. If it's one could be if the beads, instead of being round, if they were square. Because if they were square, they'd fit together better. So there'd be less holes. That's one answer. Or mix them. That's the answer most people who got it right gave me. By mixing them, you take the holes and you fill them in with other beads. So now there are less holes when you mix them. So the answers could have been unsorted, angular, I think I still spelled that wrong. Or the other one would be tightly packed. Meaning, I could take these beads and put some pressure on them and jam them together a little bit. And that would make the pores smaller. Now, I can't really do that with these, but with real soil, you can. Yeah, I can't do the plastic beads are plastic beads. They're not really changed.
Like the Orbeez.
They're, yeah, like if you squished Orbeez together.
Those were.
Does anybody have any other questions? We need to practice vocab. Now, we only have about 11 minutes left. So we do not have time to sit here and go through all of every single question. No, we're gonna still have this, I'm gonna give you the answers from last night, the homework that you guys had to do over, over the weekend. Sorry, I had a break, you did not. I actually did not check homework yet. Did you all do all of the homework?
Yeah,
You were absent.
I wasn't
Aaliyah, you were absent.
all the way to page 9.
That's fine. Did you do all your homework? How many did you get done or none? Huh? None? Did you get all your homework done? Just tell me where you stopped then.
Stopped at
Just don't look at the numbers. Oh, you did all, you were absent. Did you do all your homework? 16 through 20? Okay. Okay, that's good. You did it all?
Thank you.
You know?
That's great.
Okay. Awesome.
Right? Jeffrey's like, field those again.
They took your word for it.
Yeah, and Charles.
What question did you get?
Oh my God.
I mean, not. Better than a zero, you're right. Okay, yeah, I wonder, did you write it down? No, okay, I was just kidding, I was just asking. I kind of noticed that as a trend, that if we forget to write it down, then we forget we have it. But if we had just written down science homework, pages 15 through 19, and then you looked at that again when you were saying, wow, I wonder if I had homework, then you'd know that you didn't. By the way, let's all write down tonight's homework. 21 and 22. So you can do it a couple ways. Yeah, I often see people do labeling it at the bottom, homework, and then circling homework. The dilemma with this is you gotta look through the pages and figure that out. But if you had wrote it down in an agenda, just saying, you would have remembered. I write down every haircut, doctor's appointment, dentist appointment, chiropractor appointment, vet appointment. If I don't write it down, I'm not showing up. The problem with all of those is if you don't show up, you get charged. Why? Because then it's a waste of the hairdresser's time. She doesn't cut hair, she's not making money. So she will charge me if I don't show up. So not doing homework, okay, fine, you get a zero, but you do that as an adult and you just don't show up to things you're supposed to, you will be losing money. And it's a waste of time and waste of money. Sure, if it's court and you don't show up, I guess you're in big trouble. So your homework tonight, I actually just circled the wrong ones. 21 and 22 is homework. So I don't know what you guys circled, but make sure you circled 21 and 22. Starting on page 15, I'm gonna give you the answers. I don't think we got all of these notes.
No.
We will do that first thing tomorrow, okay? Let me double check that your homework does not include. There are a couple questions on that. I think we might have gotten enough of it. If not, we'll go through it tomorrow. Ready for the answer starting on page 15?
3.
Number 1 is 3, good. Number 2 is 3. Number 3 is 2. If you got them wrong, change your answers right now. Page 16. 4. 4 is 4. 5 is 2. Did anybody think to themselves strong seasonal winds while reading this?
Yeah.
Okay, good. Mrs. Brown will be proud. Number 5 was 2 if I didn't say that. Number 6, 1, 7, 2, 8, 3. Again, guys, notice how I'm underlining important stuff. I didn't cross off too much on this, but I definitely underlined things I needed to remember. Number 9 is 1, 10, 4, 11, 4, 12, 1, 13, 2, 14, 2, 15, 3, 16, 3, 17, 4, 18, 4, 19, 1. We'll stop there. We'll do page 20 tomorrow. But what ones did you get wrong?
Oh,
Which one?
I got
What number?
18, I got 13, 12, 15.
So 12, 13, and 15?
Yeah.
Okay, let's start there. Let's start with 12. The curving of these planetary winds is the result of. So notice how they don't just go, they're not like this where they go straight down the globe. What about the earth makes them curve? It's the fact that the earth is spinning. And that is called the rotation on the Earth's axis. So if the Earth was standing still, these arrows would go straight down or straight up, depending on which ones they are. But because it spins, it makes it look like the arrows curve. A wind belt that has the greatest effect on New York State. Can I ask how many of you picked Northeast trades, answer 3? Yep, I know why, because how'd you figure out where New York State was?
I don't know, that was a long time ago.
Okay, here's how I think you did it. There's a picture of the globe. You know we're up here somewhere. And then to you, it seems like we're more like right there, right? Seems like where New York State might be.
No, it's like, I mean, it's like.
Okay, okay, so you thought it was here?
The way I thought of it, we go North America, it's like we kind of.
Yeah, but it's not though. And how do I know it's not? It's because I look at a map. So I look at a map.
Outside the Pacific Plate.
Yeah, here's the center. Now also, guys, remember that the longitude part's not super important because the Earth spins. So North America can be anywhere. So when you said it, I had it here and you're like, no, it's over there. That doesn't matter because the Earth spins. So at any point it could be here or here or here or here. But where latitude-wise, you can see that all of North America, so from Florida up to Canada, is 30 degrees to 60 degrees. All of North America is in this section here. Or even better, you could have gone to this map and saw that Buffalo has a latitude really close to 43 degrees. Well, here's 30, here's 60. 40 would be in here. There you go, prevailing southwesterlies. And number 14, I have a vocab question. What does the word converge mean? Come together. That technically we learned when we talked about plates, but that's not a science word. Guys, what does it mean if a bunch of teenagers converge in the woods?
They meet up and loiter.
They meet up and they loiter, they hang out, they have a party. And by the way, if a bunch of teenagers were hanging out in the woods and the cops showed up, what would they do? They'd go pew in a bunch of different directions. So if they're converging in the woods, what vocab word do we use for when the cops show up and they're converging in the woods? They unconverge. There's a word for that. Not it's diverge. Just saying. So converge means come together. And we want the trade wind. Well, there's a trade wind. There's a trade wind. Here's where they're coming together. Notice it's wet. So right away, since we know it's wet, I can get rid of the 2 dry answers. Now, would that location be cool and wet or warm and wet?
Warm and wet.
How do you know it's warm? How do we know that where they're converging right here is warm? Because it's the equator. It's warm. Number 15, Earth's entire equatorial climate zone. Do you guys know what equatorial means? What's it sound like? Equatorial. Oh, it does sound like that. Equator. Equatorial zone means it's near the equator. If it's near the equator, will we have high or low pressure, and will it be wet or dry? Luckily for you, there's a reference table that tells you the equator's wet. So again, wet, not 2, not 4. Now we got to decide, is it low or high? Now I have them labeled.
It's 3.
How do I know though the equator's low pressure? It's not there. That was my handwriting. How do we know the equator is low pressure? The arrows. Remember, the arrows go from high pressure to low pressure. So we know it is wet and low pressure. I think we have time for 2 more. Cody, what's another one you got wrong?
I got 19.
19 wrong. I thought you didn't get that far.
Oh, wait, my bad, sorry. I got
11. Compared to the climate conditions of a dry inland location, climate conditions influenced by a nearby ocean. So an ocean, which is a large body of water, similar to Lake Erie, yeah, a lot bigger, but similar. If it's a large body of water, what does Lake Erie do for our summers? Does it keep us hotter or cooler in our summer? Cooler. And does it keep us warmer these both say cooler summers, warmer winters. Does a cooler summer and a warmer winter give us a large range or a smaller range? Smaller. If we're slightly cooler in the summer, warmer in the winter, we have a lower range in between. So that's a concept you just have to remember. The last one I think I want to go over is number 10. This map is a map of rainfall. I learned that in the reading. It says the ISO line represent inches of rainfall per year. They want to know who receives the least amount. Kingston, Old Forge, New York City, Plattsburgh. None of those cities are labeled. So how do I know where they are? Use your map thing in your reference table. You match up these and this, and you see that Kingston is here. Old Forge, Plattsburgh, New York City. Plattsburgh is the lowest.
And they played their first official game.
Don't forget to do your homework, 21 and 22.
Dr. Walker.
Yeah.